This is 2.4.1. We're given a list of x values and a list of probabilities. I find it easier to kind of make a little table. Part A, we're supposed to find the expectation of x, or fancy way to say the expected value of x. Now, to get that, we're just going to sum up each x value times each probability. So in our case, that would be -2 times its probability of 1/3, plus 1 times its probability of 1/6, plus 4 times its probability of 1/3, plus 6 times its probability of 1/6. You'll notice that the textbook, so I got 1.83 as a decimal because when I put in my calculator, I usually get decimals. I prefer decimals. It's the same thing as what the textbook got, they just did fractions. You are welcome to leave it in fractions or decimals. I just feel like decimals are easier to see and visualize. Okay, now part B, it asks us to find the variance, but it wants us to understand the two formulas. Now the reason we have two formulas is just because the second one is a lot easier to use. And so part of the reason that we're doing this is to help you visualize why that second one's a lot easier to use, especially before we had calculators. Okay, so this formula looks very nasty. It's not usually the one I'm ever going to use when I do it by hand, but I'll show you what it means. Okay. So it says the expected value of, you're going to take each x value minus the expected value, square it, and then take the expected value of that. So in our case, we know what this expected value is right here. We just found that. So it's actually going to be the expected value of each x value minus 1.83 squared. And that's what we have to take the expected value of. Now, anytime you want to take the expected value of anything that's besides just the x, that's what you plug into like the x box. So this will be the summation of each x value minus 1.83 squared times the probability of that specific x value, if that makes sense. So if you want the expected value of like x squared, you put x squared here in the parentheses. If you want the expected value of 3x, you put 3x in the parentheses, and then it's just times by the probability. So in our case, we'd have to do like the first x value is -2 minus the average of 1.83 squared times the probability of 1/3. Plus the next one, it has the x value is 1 minus the average of 1.83 squared times by its probability of 1/6. Plus our next one is 4 minus 1.83 squared times 1/3 plus 6 minus 1.83 squared times its probability of 1/6, which gives me 9.47. Now again, this is not the easy way to do it. This is the theoretical definition of variance. Variance is supposed to tell us how far each x value is from the mean. So -2 minus 1.83, that's telling you how far the x value is from the mean. And then we times it by its probability because that tells us like how many of those x values we probably get if we did this lots of times. Okay, so it's kind of timesing by its probabilities is kind of giving you that like weighted average. Now, again, that's very difficult to do without calculators and computers. So we figured out we can rearrange things mathematically and use this formula. So the variance of x is equal to the expected value of x squared minus the expected value of x squared. So we do this in two steps. We've already found the expected value of x, but we do need to find the expected value of x squared. Okay. This is fairly simple to do. It comes back to what I was saying before. If you want the expected value of x squared, then you're just going to do the sum of each I value squared times its probability. So whatever you want to find the expected value of, that's just what you plug into these parentheses. So we'll take each x value, so like our first one is -2, squared times by its probability of 1/3. Plus our next one, which would be 1 squared times 1/6, plus 4 squared times 1/3, plus 6 squared times its probability of 1/6. Which gives me 12.83. So that's the expected value of x squared. Now for step 2, we say, well, the variance of x now is equal to the expected value of x squared, which we just found, minus the expected value of x squared. So we just found expected value of x squared is 12.83. Minus, now come back up, the expected value of x is 1.83, so we just have to square that. This gives me 9.48. Notice I got the same thing with both tricks. The difference here is just rounding because I used decimals, they used fractions, they didn't round at all. That's why we're just a little bit off because we rounded.